So on the previous video, we explained what is cryptography and what exactly cryptography is providing when it comes to security, confidentiality, and integrity. We didn't talk about integrity yet. We spoke about the main definition, which is what is a text and what is a cipher. And most important, what is an algorithm and what is a key. And we agree that all algorithms are known how they are working, they are open, while what is the secret part is the key. And whenever you have a bigger key, this actually will make it harder to break, except it's taking too much processing. On the following video, video, we are going to talk about the symmetric and asymmetric encryption. And I would like you to bear with me because actually this is a quite important subject and it will help us to explain some terminology like digital signature or digital certificate and so on. So what is symmetric? The most common one in cryptography is the symmetric key. Symmetric key, which is one key to be used for encryption and decryption. So for instance, when we clear a text like this one, so assume that I'm writing a text, good morning, and I select it and I go to encrypt and I choose any kind of encryption. I'll choose Caesar and I'm going to change it. Instead of writing letters this time, I'm going to write number, changing 6 number or shift the number 6 number. So and encrypt, it will give me a cipher text. It's English, except it's not readable. Now, to be able to read that, or if you are sending that to someone from his side, to be able to read that, he need to have the same key. I mean, unless he has the same key, he will not be able to recover that. So you are using one key for encryption, but also you can only use the same key for decryption. It's one key for encryption and decryption. Now we have two problems here. Number one, how I'll be transferring the key. I mean, the first problem that we usually face in symmetric encryption is that the way for transferring the key. I cannot send someone an encrypted mail and attach the key with the mail, because whoever going to compromise this email, he'll be able to get the key. So this will not be effective. So I need to consider what we called out of band. Now I need to send the mail somehow, and then I need to send the key in using a different method, which is considered an overhead. If you are an organization and people sending and receiving encrypted mail, now you need to think about the different method for sending the key. So it's kind of overhead. The second part, or the second problem with the symmetric encryption, is the number of key. So the problem with symmetric is that it produces a huge amount of key, and it has a formula for that. So for instance, the formula is n multiply n minus 1 divided by 2. So for instance, assume that your organization has 10 people. How many keys do you have? N is the number of people. So you have 10 multiply 9 divided by 2, which will equal 45 key. Imagine that you have 100. So this will be 100 multiply 99 divided by 2. So you're going to notice that whenever the number of people increase, the amount of key will increase too much. And this will actually affect the business, because the problem with key that you need to create them and you need to manage them and store them and dispose them. I mean, they require a lot of administrative work. So the second problem with the symmetric encryption is the number of keys. So symmetric, which is the most common one, things like MD5, MD4, DES, the common one, all those are symmetric encryption. So the problem with them is that number one, you need to consider an out of band. So you send the document with one way, then you send the key with another way, which is an overhead. Number two, it's that the problem with symmetric is the large number of keys. But the advantage of using them, they are not taking that much of processing. I mean, you know, it's quite easy to use. That's why they are very, very common. We have another kind of encryption is called the asymmetric encryption. And asymmetric, it's quite different. Let me show it to you on the presentation. Asymmetric, for each user, he got two different keys. Let me show you on the presentation. Those are some of the symmetric encryption protocol, and as I told you, they are not secret. The secret part is the key, but I can tell you how DES is working, or 2DES, or AES, or so on. So yeah, this is a problem with symmetric, the transportation and the number of keys. Now the asymmetric, it's kind of different in a way that each user has two different keys. In asymmetric, each user has two different keys. A key called a private key and another key called the public key. So if we have an organization that has 10 people, each user or each one of those people has two keys, a private key and a public key. And those keys are mathematically related. So each key are doing just one function. So if you have a text and you encrypt that with a public key, you can only decrypt it with a private key. It cannot be decrypted with the public key again. If you decrypt it with a public key, it can only be decrypted with the private key. So how that can be used? Okay, I'll give you an example, and then I'll show you some realistic scenario. Assume that we have 5 different employee A and B and C and D. If we are implementing an asymmetric encryption, so that means that each of those employee has two keys, private and public. Public key are available for anyone. I can ask for your public key, no problem. So public key, it's like they are somewhere inside the organization where anyone can ask for any employee key, public key. While the private key, it's on your pocket. It's only reachable by yourself. A pocket, I'm just saying that as an example, but it's inside your computer. So if I need to send you an email, I will check for I will get your public key, because the public key, it's available for anyone. So I'm going to get your public key. I'm going to write this email and I'm going to encrypt it using your public key. And as you know, whatever is encrypted with your public key can only be decrypted with your private key. So now I'm sure that whoever going to get this email, he will not be able to read. Only yourself that holds the private key on your computer, you'll be able to decrypt that. This is an automated process. I mean, you are not doing anything, except you should understand how it works. If you need to send me an email, you're going to check for my public key, search for it, and encrypt the text, and then send this text, and only myself, I'll be able to decrypt it using the private key. Let me give you a real example. Let's open a website like Google. Now, those encrypted private key and public key are called the digital certificate, or one of the names actually is digital certificate. So let me give you an example to clarify that. Let's go to Google website or Facebook or any website that has an HTTPS. So when you open this website, you notice that there is a yellow lock here, right? And this lock mean, if you click on it, that this website has a certificate. Okay, so let's see what exactly this certificate mean. I don't know, this new Microsoft Explorer, it's not that friendly like before. Let me show you that on any other browser. So if I open Chrome or Firefox, let's open any secure website. And you open a site, how do you know that this is a secure website? Right? You see this lock, right? And this lock means that this site has something called a certificate. I know that you should usually check HTTPS, but HTTPS will be showing with this lock. Now let's explain what exactly is this lock. This means that this site holds a certificate. A certificate, it's something that you can buy. If you have a website and you need to make sure that your transaction is safe, you can buy a certificate for something called certificate authority. And we have like around 13 major ones. We have the VeriSign, we have GoDaddy, we have Google's, many of them. So assume that you're going to use this website and you're going to do some financial transaction and write your credit card. How do you know that it's secure? Number one, when you check and you see that you have a certificate here, this is actually will show you or will indicate that this website is a real business. It's not a fake one. Number two, okay, what if this is a real business? They are not thieves, but still there is some risk, because when I'm writing a credit card, maybe someone is sniffing the network and he'll be getting my credential information on my credit card. Now, if you click here and you go and you check the certificate information, you're going to see that, you know, this certificate has been given to this specific website and this is secure and so on. And password view certificate. Okay, let's go to view certificate. And notice that when we are going to check certificate, you should find the public key. What is the public key? Details. Certificate. It should be one of those. Okay. So let's keep, here you go. So this is the public key. Okay, let's relate that to what we just explained. Any website who need to secure their transactions, they're gonna buy a certificate. This certificate has two different keys, a public key and a private key. A private key are kept on Google website. Okay, the public key will be sent to you, and you, whatever you are writing, it will be encrypted using your public key. I'm sorry, using your using Google public key. So whatever you are writing in this website, this will be encrypted using Google public key. They will gonna send you, Google did send you their public key. So anything you are writing, credit card information, are saved using their public key. And whatever is encrypted with Google private public key can be decrypted with Google private key. So now I'm sure that only Google will be able to decrypt my text. So this is an implementation on private and public key. It can be used on a website, it can be used internally. Some organization has this certificate authority inside the company where they will issue for each employee two keys, private and public. And anything that you need to send someone, you're gonna check for his public key and encrypt it and make sure that only this person or individual will be able to decrypt this text. Now, this can be used in an opposite way. Let me explain. We agree that whatever is encrypted with the public key can be encrypted with private key and vice versa. So if you can encrypt with a private key and it can be decrypted with a public key. Okay, here is the scenario. I create an email and then I decrypt this email with my private key that I have only on my machine. When I send this email to anyone, how he'll be able to read it? He needs to decrypt it with my public key. But my public key is available for anyone. What is the use of something like that? This is used for what we call non-repudiation. So what I'm doing right now, if I send an email with my public key, I'm not looking for confidentiality. When I'm sending an email with my public key, I'm sure that anyone can read it. But the benefit of that is I cannot deny that I sent this email. So if anyone were able to encrypt it using my public key, I cannot say that I didn't send this email. So this is not used for confidentiality, it's used for identity, for non-repudiation. I cannot deny that I sent this email. And this is the idea of digital signature. You are sending a text with your email that is encrypted with a private. So when it reaches someone and he can decrypt it using your public that is available for anyone, now he's sure that this email has been sent by you. So this cannot be a fake email. So this is the definition of digital certificate and digital signature. Let me know if you have any question or if anything was not clear enough.